we have first point introduction to Napier and decibel. So your alpha is nothing but the attenuation and it is given by IS upon I1 and its unit is Napier, ln IS upon I1. And relationship between attenuation in dB and attenuation in Napier. So attenuation in dB equal to 8.68, attenuation in Napier 8.686, attenuation in Napier. Then this is nothing but your constant K low pass filter, L by 2 C. You must remember this diagram, L by 2 C. So this is nothing but constant K low pass filter, L by 2 C. Then it has design impedance under root L by C. Design impedance is under root L by C. So you have to remember the formula of design impedance under root L by C. And cutoff frequency 1 upon pi under root LC. So you must remember the formula of cutoff frequency 1 upon pi under root LC. Then your attenuation is given by this formula 2 cos h inverse f by fc. Unit comes out as Napier. Here important point, unit is Napier. 2 cos h inverse f by fc. So this formula also you are supposed to remember. Then phase shift is given by this formula 2 sin inverse f by fc and unit is radian. 2 sin inverse f by fc. Then what is meaning of designing any filter? Design means, remember always you will be becoming engineer. What is meaning of design? Design means finding out the component values. So for low pass filter we have the formula for C as 1 upon pi R0 fc and formula for L as R0 upon pi fc for low pass filter. So it is expected that you should remember this formula also, and you should study like means how is it means you should study like how you can get it for high pass filter also. What are the changes in the formula? So that comparative study you must do. Then these are the few questions which we have solved for designing. Then your attenuation is 0 in pass band. Attenuation value is 0 in the pass band. Then about high pass filter. So 2C, 2CL. You must remember the diagram 2C, 2CL. So we are just learning only T type of network. We have pi type of high pass filter also, but we are not going into that. I have made it very simple. For high pass filter 2C, 2CL. Okay. Then design impedance is same. Both low pass, high pass have the same design impedance under root L by C. And here the cutoff frequency is 1 upon 4 pi under root LC. 1 upon 4 pi under root LC. Attenuation, what is the change here? In low pass filter it is cos h inverse f by fc. For high pass filter it is fc by f. So you must do the comparative study. So if you are remembering the formula for low pass filter, then you should know what are the changes. These f and fc are interchange. Then here we just have minus sign, that is the only change with low pass filter and high pass filter. So for low pass filter beta is 2 sin inverse f by fc. For high pass filter it is minus and fc by f. Okay. Then design equation for L for C, this is the formula 1 upon 4 pi R0 C fc, and for L it is R0 upon 4 pi fc. So 1 by 4 factor is coming. If you do the comparative study of low pass and high pass, here 4 factor is coming in the denominator. Okay, so this is all about theory. Let's come to the questions. So you have to identify it is which filter. Just quickly reply in the chat box. It is which type of filter? L by 2 C. L by 2 C. It is which type of filter? For your exam only this type of questions will come. So you must remember the diagram. So it is nothing but low pass filter. L by 2 C. L by 2 C. It is a low pass filter. Okay. So L by 2 value is 10 Henry. L by 2 value is 10 Henry. So L equal to 20 Henry. L equal to 20 Henry. First answer, L equal to 20 Henry. So we got the first answer, L value as 20 Henry. Then what is design impedance? R0 equal to under root L by C. Under root L by C. L is 20. C is 0.01. 20 divided by 0.01. So this type of questions will come in the exam. So one circuit may be given, they may ask what is value of design impedance, what is value of cutoff frequency. So 20 upon under root pi 0.1 means it is under root 200. Someone has given the answer under root 2. No, it is not under root 2, it is under root 200 is the answer. So design impedance value is 14.414. Very good, 14.14. So ऐसे टाइप के क्वेश्चंस आपके एग्जाम में पॉसिबल है, ठीक है। एक डायग्राम गिवन रहेगी, आपको डिजाइन इंपीडेंस पूछ सकते हैं, आपको कट ऑफ फ्रीक्वेंसी पूछ सकते हैं, आपको फिल्टर कौन सा ये पूछ सकते हैं। तो ये L/2 C था, मतलब ये लो पास फिल्टर था, इट इज अ लो पास फिल्टर, ओके। देन डिजाइन इंपीडेंस इज अंडर रूट L by C, L की वैल्यू पता है, बट ये L नहीं है, 10 हेनरी नहीं है, L/2 रहता है, L/2 इक्वल टू 10 हेनरी, सो L इज 20 हेनरी। यहाँ पे भी आप मिस्टेक कर सकते हैं। Then cutoff frequency is Fc equal to 1 upon pi under root Lc. 1 upon pi under root Lc. So 1 upon pi under root Lc. So it just put the value of L. L is 20 Henry. C is 0.1 farad. So it comes out as 1 by pi. Anyone just calculate under root 20 into 0.1. Okay. I want the overall answer, Mansi. Overall answer of cutoff frequency. What is the overall answer? 0.025. 0.225. 0.225 hertz is the cutoff frequency. Okay. So I hope you have got the idea what type of questions are expected in the exam. One diagram is given, the question can be identify the filter, question can be calculate design impedance, question can be calculate cutoff frequency. और दूसरे टाइप के क्वेश्चंस कैसे पॉसिबल है? इन दैट R0 will be provided, cutoff frequency will be provided, and what is value of L for low pass filter, what is value of C for low pass filter, what is value of L for high pass filter, what is value of C for low pass filter. This type of questions are possible. So only thing is that you must remember the circuit diagram, you must remember the diagram. The next thing is that you must remember the formulas. Okay, chalo, next question. Before that, what is R0? What is name for R0? Design impedance. R0 is called as design impedance. R0 is called as design impedance. What is Fc? Cutoff frequency. What is alpha? Attenuation. What is alpha? Attenuation. What is beta? Phase shift. Beta is phase shift. And इनके formulas for low pass and for high pass. Okay, next. अगर ये लो पास फिल्टर रहता तो यहाँ पे क्या कंपोनेंट आता है? RLC क्या वैल्यू आती है यहाँ पे? जल्दी से बताओ चैट बॉक्स में. Suppose this is a low pass filter. What is the component here? R, L or C? L by 2. Very good. It is L by 2. It is L by 2. L by 2, L by 2. Yes. And this is nothing but C. So this is the diagram of low pass filter. अगर suppose ये high pass filter रहता, suppose ये high pass filter रहता, तो यहाँ पे component क्या आता? देखते कितने लोगों को याद है? Suppose this is a high pass filter. What is the component here? 2C. Component is 2C. 2C, 2C, L. Okay. Chalo, in the chat box you are giving the answer. So I hope you can remember this. So these are the standard diagrams. Next. Suppose a constant K low pass filter has cutoff frequency 1 kHz. So Fc given as 1 kHz. Okay, constant K low pass filter has cutoff frequency 1 kHz. What is value of alpha? That means what is value of attenuation at 500 Hz? What is value of attenuation at 500 Hz? Oh. So see here. So it has cut off. It is a low pass filter. It has cut off frequency 1 kilohertz. It has cut off frequency 1 kilohertz. This is the frequency response of low pass filter. In the first video, I have explained the frequency response. Okay, so this is the frequency response of low pass filter. Okay, then next is at what frequency we have to calculate alpha? At 500 hertz. We have to calculate alpha at 500 hertz. So your alpha is always 0. Alpha is nearly 0 or it is always 0 in pass band. In pass band. Alpha is 0 in the pass band. So the answer for this question is alpha equal to 0. No need to calculate. हमेशा अल्फा क्या रहेगा? Attenuation in the pass band 0 because it is passing the signal. No attenuation. It is passing the signal. Okay, इसलिए attenuation नहीं रहेगा. अल्फा का मतलब क्या है? Attenuation. No attenuation. That's why alpha is 0 in the pass band. This is the note also I have given. This keynote also I have given. Attenuation alpha in pass band is nearly 0. See here. In the video I have given the note. Okay. So next. If attenuation is 7.4 dB, what is value of alpha in Nepper? So we know that alpha in dB equal to 8.686 alpha in dB, alpha in Nepper. So from this you can get the value of answer. Anyone answer? So alpha attenuation in Nepper. You must keep calculator while attending lecture. Very good, 0.85. So 7.4 divided by 8.686. So its value comes out as 0.85. Okay, so this type of questions are also possible in your exam. If it is MCQ type exam, definitely this type of questions are possible. Okay, this is the 7.4 dB. I may give you some different value. Are you getting what type of questions are possible? So ये क्वेश्चन में क्या गिवन था? अल्फा गिवन था डीबी में. हमको अल्फा की वैल्यू पूछे नेपर में. सो हमको रिलेशन पता रहना चाहिए. अल्फा इन डीबी इक्वल टू 8.686 अल्फा इन नेपर. Okay, chalo next. Low pass filter has cutoff frequency 1 kilohertz. What is attenuation in Nepper at 2 kilohertz? What is attenuation in Nepper at 2 kilohertz? So cutoff frequency is 1 kilohertz, and this is pass band. This is pass band, and this is stop band. We have been asked the value of alpha at 2 kilohertz. So 2 kilohertz is away from the. It is not in the pass band, it is in the stop band. 2 kilohertz is present in the stop band. So we have to use the formula. Now answer will not be 0. So we have to use the formula. Very good. Alpha equal to 2 cos h inverse. 2 cos h inverse f by fc. For low pass filter it is f by fc. For high pass filter it is fc by f. Okay. So some students have put the values. Cutoff frequency 1 kilohertz and f given 2 kilohertz. So they have calculated answer as 2.63. Very good. Good job. 2.63 Nepper. So इस टाइप के क्वेश्चन भी पॉसिबल है एग्जाम में. दिस टाइप ऑफ क्वेश्चंस आर पॉसिबल इन द एग्जाम. लो पास फिल्टर कट ऑफ फ्रीक्वेंसी गिवन रहेगी, आपको एटेन्यूएशन पूछ सकते. ओके, सो जस्ट यू हैव टू यूज द फॉर्मूला and get the answer. So one note, alpha is 0 in the pass band and beta we are calculating in the pass band. मैंने alpha बोला, beta के बारे में नहीं बोला. Beta we always calculated in the pass band. Beta phase shift we calculate in the pass band. Okay. Okay. Next question. Low pass filter has cutoff frequency 1 kilohertz. Low pass filter. पहले तो आपको filter देखना है, low pass है कि high pass है, और accordingly proper formula use करना है. A low pass filter has cutoff frequency 1 kilohertz. What is phase shift beta at 200 hertz? So we know the formula of beta. Beta equal to 2 sin inverse f by fc. 2 sin inverse f by fc. This is the formula. So this type of questions are possible in the exam. 2 sin inverse f is 200, fc is 1 kilohertz. So just calculate the value. 1 kilohertz means 1000. Anyone? 23.07. Unit is radian. 23.07 unit is radian. Simple questions एकदम simple है. But अगर student को पता ही नहीं है, see question is in the statement form. If the student doesn't know the formula of phase shift, then how he can calculate? That is the point. So unit is radian. Okay. Next question. What is the filter? It is which filter? CCL, or you can say 2C2CL. So it is a high pass filter. It is a high pass filter. So this is nothing but high pass filter. So from this 2C equal to 0.2 farad. If I compare 2C equal to 0.2 farad, so C equal to 0.1 farad. Therefore C equal to 0.1 farad. 0.2 upon 2, 0.1. 0.2 divided by 2 is 0.1 farad. L is 10 Henry. Okay, what is formula? 10 Henry. What is formula of what else we have to calculate? We have to calculate cutoff frequency. We have to calculate cutoff frequency. What is formula of cutoff frequency for high pass filter? आपने पहले पता कर लिया ये हाई पास फिल्टर है. What is formula of cutoff frequency? 1/4 pi under root LC. फॉर्मूला भी पता रहना चाहिए हाई पास फिल्टर का. 1/4 pi under root LC. So just substitute the value, you will get the answer. 1/4 pi 10 into 0.1 1 under root 1 1. So 1/4 pi is the answer. 1/4 pi is the answer. Okay. I think you are calculating. I will give you time. Okay, 0.079. 0.079. For making calculation easier, I have used these values. In exam, the values can be different. The values can be different, and definitely it will comes out as properly like 500 hertz or in kilohertz. We may use millihenry, microfarad. So your answer will be in kilohertz range in the exam. So this is just for your understanding. What type of questions are expected and what type of preparation you must do. The next we have to calculate design impedance. So design impedance is R0 equal to under root L by C. What is value of L? L is 10 Henry, C is 0.1. L is 10 Henry, C is 0.1. So 10 divided by 0.1. Answer 10 divided by 0.1 under root 10. 10 ohm. 10 ohm is the answer. So जैसे आप अभी यहाँ पे कैलकुलेट कर रहे हैं ऐसी फास्ट आपको एग्जाम में कैलकुलेट करना है. Because you will be having less time. Very good. 10 ohm is the answer. Very nice. Around 39 students are there. I don't know how many of you are getting these formulas and filter type. अगर अभी तक जितना भी मैंने पढ़ा है सब लोगों को समझ में आया तो reply in the chat box with S if you have understood. Okay, chalo, thank you. Next question. For constant K, high pass filter, what is attenuation at 2 kilohertz? If cutoff frequency is 1 kilohertz. So first of all, you must plot the frequency response. You must plot the frequency response. It is a high pass filter having cutoff frequency 1 kilohertz. So 1 kilohertz से ऐसा start हुआ. This is the frequency response. This is the frequency response. Now 2 kilohertz, 2 kilohertz somewhere here. X-axis is frequency, y-axis is gain. Your x-axis is frequency, y-axis is gain. So what is attenuation? Whether you have understood the concept? Zero is the answer. Very good. So within 10 seconds, you should be able to answer. So as we can see, we have to calculate attenuation at 2 kilohertz. The 2 kilohertz is present in the pass band. This is pass band. This is pass band and this is stop band. So the 2 kilohertz is present inside pass band. So inside pass band alpha is 0. Inside pass band alpha is 0. Okay, and what is the basic formula of attenuation? Alpha equal to 2 cos h inverse fc by f. Formula is fc by f for high pass filter, because in the question they have mentioned high pass filter. So ये चीज भी पढ़ना बहुत important है, high pass filter. Okay, so 2 cos h inverse fc by f. If you put the values 2 cos h inverse fc is 1 kilohertz. This is 2 kilohertz. So its value comes out as 2 cos h inverse 0.5. And if you try to calculate it in the calculator, calculator will give you math error. I hope you are getting the math error. Cos h